Okay, so section 11.5 is on what we call the binomial theorem. So I'm going to start out with some basics, and then we're going to notice that there's a pattern involved in these. So if I have a plus b squared, we all know by now that a plus b raised to the 2 is not a squared plus b squared. We all know that, right? Remember I called that the freshman dream. It is not a squared or a squared plus b squared. What we have to do is we have to FOIL. We have to multiply a plus b by itself, a plus b. So when we do that, I get a times a is a squared. And then I have a times b is ab. And then I have b times a is ab. And I have b times b is b squared. So when I combine my like terms, I have a squared plus 2ab plus b squared. Okay? All right, and then we do it again. So let's say I want a plus b cubed. Well, I know that it's not a cubed plus b cubed. It doesn't work that way. I have to do a plus b times itself 3 times. Okay? And so we do one thing at a time. We can't multiply all 3 of these all at once. So we do a plus b times a plus b. Well, luckily we just found that. So a plus b times a plus b is going to be a squared plus 2ab plus b squared. And then I'm going to multiply by another a plus b. Okay, so I'm going to take that when I have 2 polynomials multiplied by each other. I'm going to take the a squared, I'm going to multiply it into both things in the second polynomial. Remember this from like chapter 6 or something. Okay, so I'm going to have a squared times a is a cubed. And then I have a squared times b is a squared b. And then I take my 2ab and I multiply it into both things. So I have 2ab times a is going to be 2a squared b. And then I have my 2ab times b is going to be 2ab squared. And last but not least, I take my b squared and I multiply it by each thing. So when I do that, I have ab squared plus b cubed. And I combine anything that's like terms. Now, like terms not only have the same variables, like a and b, but they have the same exponents on those specific variables. So like I can combine a squared b and I can combine 2a squared b to get 3a squared b. And I can combine 2ab squared and ab squared to get 3ab squared. And then plus b cubed. That is your answer. And we could do this over and over again. We could do a plus b to the 4th. We could do a plus b to the 5th. Or I can tell you the shortcut for doing this. There's a shortcut. All right, so if I have a plus b to the 4th, the pattern looks like this. A to the 4th plus 4a cubed b plus 6 a squared b squared plus 4ab cubed plus b to the 4th. So start kind of staring at it, thinking, what's a pattern? Yeah, what do you see?
Well, A's goes from 4, 3, 2.
Yeah, the A's go 4, 3, 2, 1, none.
And then B goes to 1, 2, 3, 4.
B goes none, 1, 2, 3, 4. Do you see what he's talking about? So 4, 3, 2, 1, none for the A's. And then the B's go no B's, 1 B, 2 B's, 3 B's, 4 B's. Okay, so there's a pattern with the exponents. But then we have these numbers out front, and we're like, oh, well, what's happening with the numbers out front? So my numbers are 1, 4, 6, 4, 1. So I don't know. So let me show you the next one. The next one, a plus b to the 5th, is going to be a to the 5th plus 5, a to the 4th times b, plus 10, a cubed b squared, plus 10, a squared b cubed, plus 5, a to the 1st, b to the 4th, plus b to the 5th. Okay. Another thing with the exponents, notice how the exponents are always adding to be whatever power you had originally. So when I have a plus b to the 5th, right, I have a to the 5, and then I have 5, a to the 4, b to the 1. 4 and 1 make 5. And then the next powers are 3 and 2. That makes 5. And 2 and 3 makes 5. So that's another pattern. But the thing that's confusing is it's like, well, where am I getting these coefficients, these numbers out front? You know I love to memorize numbers. I don't. I have not necessarily memorized this. I actually have. But I don't know, like, a plus b to the 6th or 7th or whatever off the top of my head. Okay? What I'm doing is I'm using something called Pascal's triangle. And Pascal's triangle looks like this. 1, 1, 1. So I start with a triangle of ones. 1, 2, 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. Do you see the pattern? Every number that I'm writing is the sum of the two numbers above it. So when I talk about this number right here, 4, it is the sum of 1 and 3. If I have 3 here, it's the sum of 2 and 1. Right? So what should my next row be? 1, 5, 10, 10, 5, 1. Right. What about the sixth row?
1, 6, 15, 20, 15, 16.
Exactly. So it's very symmetric. Like, notice how, like, on the outsides I'm the same. 1, 6, 15, and then the middle makes 20. Okay, it's very symmetric.
Oh, I see. You have.
Okay. So if I have this next row, 1, 7, 21, right? I'm just adding the two things above to get that number. And then I have 35, 35, 21, 7, 1.
So each row serves like 6 rows and you like use your equation as coefficient.
Yeah. So if I have a plus b to the fifth, if I look at these coefficients, my coefficients were 1, 5, 10, 10, 5, and 1. Do you see it? So if I wanted to find a plus b to the sixth, I use what I call the sixth row. Now if you count, this has to be the 0 row. So 0th row. And then this is now going to be the sixth row. See why it's convenient to call the 1, 6, 15, 20, call it the sixth row. Okay, it has to do with a plus b to the sixth. So this would start out with a 1, and then I have a to the sixth. Then I'd have 6, a to the fifth, b to the 1, plus 15, a to the fourth, b squared, plus 20, a to the 3, b to the 3, plus 15, a to the 2, b to the 4, plus 6, a, b to the fifth, and then plus b to the sixth. That's what the expansion would be for a plus b to the sixth. I'm using those numbers from Pascal's triangle. Do you understand? Okay, so if I wanted a plus b to the 7, I would use what I call the seventh row to find that. Okay, one of my weird mathematician stories is this guy. His name's spelled like this. Yeah, I took French, but I still butcher his name. I used to call him Blasé, and then the French teacher told me that that is incorrect, and then it's wrong. She says it's Blaise. Blaise Pascal. Okay, so Blaise has the little story, and they all have weird stories. And his story is that he was riding in a carriage drawn by horses, and those two horses that were driving him decided to jump off of a bridge, a very high bridge, while he was in the carriage. So they, I don't know, like I guess they're committing suicide. I don't know what they're doing. They just decide to all of a sudden jump off this bridge, and the horses die. But as they're jumping off, there's a second when he is suspended and his wheel gets kind of caught on the bridge, right? So he's stuck on the bridge and he manages to escape imminent death. Like he would have definitely died. And so he's saved. And so the rest of his life, he devotes himself to God, thinks that God has saved his life, and writes a little letter to God that he keeps over his heart every day for the rest of his life. And there's a paradox with Pascal, and he said, if there is a God out there, then you should believe, because you will end up going to heaven or wherever if there is a God. But he said, if there's not a God, you should still believe that there is one, because what happens? Well, if there's not a God, then there's not a heaven or whatever. But does it hurt to believe in God? So that's like the Pascal's paradox. Does that make sense? No, it's very strange. So he was a philosopher later. All right, so anyway, so it says each row of Pascal's triangle gives the coefficient. So we've talked about this. So if I want the seventh row, I would use the one that starts out with 1 and then 7. All right, so in this little picture, I have a plus b raised to the 0 equals 1. Okay, does that make sense? A plus b raised to the 0 equals 1. Anything to the 0 is 1, except for 0 to the 0, that's undefined. All right, a plus b to the 1, that's a plus b. Do you see how that's giving you 1a plus 1b? So we have 1, and then we have 1, 1. And then the second row, that would use the 1, 2, 1. It's 1a squared plus 2ab plus 1b squared. See where these numbers are coming from. So then it's 1, 3, 3, 1, 1, 4, 6, 4, 1, and 1, 5, 10, 10, 5, 1. Just so you can see that these numbers are there. 1, 5, 10, 10, 5, 1. So we can end up doing this pretty quickly. We can multiply x plus 2y raised to the 3, and we can do it very, very speedily. Now you could always, you could always do it 3 times, like we talked about, unfoiling it out. But when you have x plus 2y to the 5th, that's not very fun. You don't want to do that. It's raised to like the 5th or 6th or whatever. You want to go the shortcut. Okay, so find each binomial expansion. So I taught this for several years, and the way that I taught it was to always write it with a's and b's. Okay, so I'm going to write it as a plus b raised to the 3. Okay, and when I taught my students this, I said, okay, well, let's just expand it if it was a plus b. That's pretty straightforward. You guys understand that? So if I have a plus b raised to the 3, I'm going to use those coefficients right here. So 1, 3, 3, 1. I always give myself plenty of room. And then my a's start with a cubed, right? Because I started out with 3. And then I go down all the way. So I'm going to have a squared, or a cubed, a squared, a to the first, and then no a's. And then my b's are going to go up. So I'm going to have no b's, b to the first, b squared, and b cubed. One way you can check is all of your exponents are adding up to be 3 for each term, right? So that's the expansion. So if I had a plus b cubed, it would be a cubed plus 3a squared b plus 3ab squared plus b cubed. So then we think, well, how is this related to x plus 2y cubed? Well, that means that x is merely just like the a value is being replaced by x, and the b value is being replaced by 2y. So I would end up getting the exact same thing, except every time I have an a, I'm going to write x, and every time I have a b, I'm going to write 2y. Okay, so I should have x is being cubed plus 3, x is being squared, times 2y, plus 3 times x, times 2y is being squared, plus 2y is being cubed. Does that make sense? I'm just replacing. I'm saying, okay, all my a's are really x's, and all my b's are really 2y. And then the hardest part of the problem is the simplifying. A lot of people will mess up on the simplifying, so you need to be very, very careful. So you're just going to go through and you're going to like multiply it out. So you're going to say, well, x cubed is just x cubed, right? But on the next one, I have 3 times x squared times 2y. So I'm going to leave it kind of expanded like that for now. So 3 times x squared times 2y. And then I'm going to have 3 times x times, what's 2y times 2y? 4y squared. And then I'm going to have 2y times 2y times 2y, so I get 8y cubed. So my final answer is x cubed plus 6x squared y, because that was all grouped together, plus 12xy squared plus 8y cubed. That's it. So do you understand what I did there? And I taught it like this for maybe 5 years, and then I was like, why am I wasting all this time writing A's and B's? Like, why don't I just start out and use, like on this next one, X, wherever I would have put an A before, I'm just going to put X, and then wherever I would have had a B, I'm just going to put negative 5. Okay, and so that's how I started teaching it, and this seems to be, I don't know, students seem to like it more. Not as much writing. Okay, so we're going to start out. And you'll be happy to know that your homework is printed this way instead of this way. So you have plenty of room to write this. Lots of room. So fill that page. All right, so on this first one, so I have k minus 5 to the 4. All right, if I'm raising something to the 4, I need the fourth row of Pascal's triangle. So you guys can flip back to your Pascal's triangle. It's right here. 1, 4, 6, 4, 1. So I put those down first. 1, 4, 6, 4, 1. And I usually go ahead and I put pluses in front of the 4, 6, 4, 1. I don't need a plus in front of the first one, but just to separate my things. And it's always nice to use colored pencils if you want, so you can kind of see what's going to the 4th, what's going to the 3, and so on. So let's say I put this one in another color. So my A is K. Do you guys see that? So everywhere I would have had A cubed, or A to the 4th, A cubed, A squared, and so on. I'm going to put K to the 4th, K cubed, and so on. And I like to put them in parentheses. It's kind of a good habit for the ones that are harder to put the item in parentheses. So I have K to the 4th, K cubed, K squared, and K. And now I'm going to go through and I'm going to put in my negative 5s. So on the first one, I have no negative 5s. You could write negative 5 to the 0 if you really want. The next one, I have 1 negative 5, then 2 negative 5s, then 3 negative 5s, and 4 negative 5s. Does this make sense how I'm doing this? It's just a pattern. So I have K to the 4th. And then, like I said, sometimes you can do this all in your head. You can kind of multiply all those terms, but I like to kind of write the intermediate step. I like to say, on this one, I'm going to have 4, I'm going to have times K cubed, and then I'm going to have times a negative 5. So that's all together as one term. And then the next one, I have 6, and then I'm going to have a K squared, and then I'm going to have negative 5 squared is 25. So those are all together as one term. You see what I'm talking about? Okay, and the next one I'm going to have plus 4 times K times negative 5 cubed is negative 125 all together. And then I have negative 5 times negative 5 times negative 5 times negative 5, which is good, 625. Okay, so you see how I got that? So you can recognize what the terms are. So I'm going to have K to the 4th minus 20 K cubed plus 150 K squared minus 500, right? 125 times 4, 500 K plus 625. And that's your answer. Yes, you would have your calculator to help you with like things like 125 times 4 and so on. Okay, does this make sense? Feeling good about it? All right, really the 4th is probably the biggest I would put on your test. I wouldn't put something to the 5th, 6th, 7th. That would be kind of crazy. I'd probably do something to the 4th or 3rd. All right, so let's try the next one. Do you guys want to try it first? Write it out? No, you just want me to do it? Is it one of those days? Yeah. All right, so I have 6m minus 5 cubed. So that means I'm using the 1, 3, 3, 1. Right, the third row of Pascal's triangle. And then I'm going to go through, and I'm going to say, oh, A is 6m. So I'm going to put 6m, and it's going to be raised to the 3, and then to the 2, and then to the 1. I forgot my little pluses. I like to put the pluses in because it does get pretty smushed sometimes. That's when you can see the separation. All right, what's my B? Negative 5. You need the sign as well. Negative 5. Okay, so I'm going to go through and I'm going to put negative 5 in. So I'm going to have no negative 5s, 1 negative 5, 2 negative 5s, 3 negative 5s. Don't you love how I always leave this spot blank? I don't know why I do that. I never I could put the first number next to the other number. All right, look good? All right, now we simplify. The simplifying is the hardest part. So if this problem was like worth 3 points on the test, I would probably give you 2 points for just getting here. Okay, and it'd just be like off 1 point for the next step. Okay, because the simplifying is a little bit difficult. Okay, so I have 6m times 6m times 6m. 6 times 6 times 6, you can use your calculator if you want. It's 216. So I have 216 m cubed. The next part is where I kind of need to see each term, what's happening. So I have 3, and then I have 6m squared is going to be 36m squared, and then I have a negative 5. So that's all one term. That all goes together. Okay? If you can do it all in your head all at once, you can do that. But I typically like to write it out. So then I have 3 times 6m times 25. And the last one is negative 5 times negative 5 times negative 5. So minus 125. So you don't have to do plus a minus 125. You just do minus 125. So your final answer is 216 m cubed What do you get when you did 3 times 36 times negative 5? Is it 540? Minus 540 m squared plus 3 times 6 times 25. It's like 18 quarters, you can think of it that way. 450. So 450 m minus 125. That's your answer. Okay, so it's not necessarily hard. It's definitely a pattern. The hardest part is probably simplifying. So using your calculator, finding each of those numbers. Let's try the next one. Okay, this is a typical test question, but I probably wouldn't raise it to the 5th. I might raise it to the 4th or the 3rd for your test. But let's go ahead and try it. So try it. You raise it to the 5th. So your numbers for your Pascal's triangle are 1, 5, 10, 10, 5, 1. So use those numbers. Right? And go ahead and try to figure out what you're going to get. So I'll give you a couple seconds to try it. All right, so we're going to have 2x raised to the 5, 2x to the 4, guys, 2x to the 3, 2x squared, 2x, right? And then you're going to go through with the negative 3y. So I have no negative 3y's. I have 1 negative 3y, 2 negative 3y's, 3 negative 3y's, 4 negative 3y's, and 5 negative 3y's. Okay, so we're going to simplify. See what I'm talking about? I always put that first one so far over. I'm like, Okay, so I get 32x to the 5th plus this next one's going to be 5 times 16x to the 4th times negative 3y, and that all goes together. All right, and then I'm going to have plus 10 times 8x cubed times 9y squared, and that all goes together. And then I'm going to have plus 10 times 4x squared times negative 27y cubed, and that all goes together. And then plus 5 times 2x times 81y to the 4th, and that all goes together. And then plus negative 3 times negative 3 times negative 3, like 5 times, is going to be negative 243y to the 5th. So as we simplify, we have 32x to the 5th minus 5 times 16 is 80, so times the negative 3 is 240. So negative 240 x to the 4th y plus 720 x cubed y squared minus 1080. Is that 1080? 1080 x squared y cubed, and then plus 80 xy to the 4th minus 243y to the 5th. That is your answer. Did anybody get it perfectly? Yeah, good. Are you lying? Faisal looked at me like he was lying. He has no like poker face at all. All right. Yes, that's your answer. Good. That's a hard one. Definitely hard. One way I can usually tell, like, if students don't have the right thing right off, like at a glance, like notice if there was a minus originally, like there's a minus here. This ends up alternating. It goes plus, minus, plus, minus, plus, minus. Does that make sense? So I look for that. I also look at my degrees. So my x's go x to the 5th, 4th, 3rd, 2nd, 1, none. And then my y's go none, 1, 2, 3, 4, 5. Jenny, did I make a mistake?
I'm confused.
Oh, it's 810.
Yeah. I was about to say
I just didn't see that 1 in there. So 810 xy to 4. All right, did you have 80 as well? Or are you at 810? Okay. So I guess Jenny gets another point. I think you're at 5, Jenny.
Well, she didn't even think that it worked.
What?
Oh, wow.
She raised her hand. She was sitting so patiently waiting for me to call on her. All right, here we go. No. All right, so this next one. So I have raised to the 3rd. Guys, raised to the 3rd. So I need 1, 3, 3, 1. All right, so I'm going to have x cubed, x squared, x, and no x's. And then my other thing is 2x, x root, or 2 squared of x. So I'm going to have one of the 2 root x's. I'm going to have another 2 root x. And I'm going to have another 2 root x. Or cubed, right? So that. Okay, and I'm going to start simplifying. Now, you have to be really good with your powers and so on. You could do this all in fractional exponents. Remember rational exponents, that section? Or you can leave them with the roots. It doesn't matter. So I'll write it both ways so you guys can see. So this first one is going to be x cubed. The next one is going to be 6x squared root x. Then I'm going to have 6, well, not 6 actually, because my 2 root x is going to be multiplied by itself, 2 root x. So what happens when I do 2 root x times itself? I get 4x. You actually get 4 absolute value of x. You remember those days? But I should have written that we assume x is positive in this case, because it's under a root originally. All right, so anyway, so it's fine. So we have 4x. We have 3x times, this becomes 4x. So I'm going to have 12x squared. And then what if I had another 2 root x? So now I have times another 2 root x. So I get 8x root x. Okay, and that can be your answer. Or you can get fancy. And you could say x cubed plus 6x to the, well, let's think about it. I have x squared times x to the 1/2. What would my fractional exponent be? X to the, not 1. Add them. 2 plus 1/2 to the 5 over 2, right? 2 plus 1/2 is 5 over 2, 2.5. All right, and then I have plus 12x squared. And then I have plus 8. What would this one be if I have x to the first times x to the 1/2? X to the 3 over 2. Yep, so you could see it like that as well. So if this was like a multiple choice answer or something like on the ACT, you would know that. All right. So let's talk about how we find a certain term if we don't want to draw the whole Pascal's triangle. So you know how your calculator tells you a million times that it's going to die? Like, it warns you for probably 2 to 3 months that you need new batteries. Has that happened to you before? It's like, get new batteries, get new batteries. All right, I have been the person who like did not get new batteries, and then in the middle of a final, my calculator died. Like, it happened to me. It was not fun. Yes, Alex?
Well,
Oh, it did. It just died. Yeah, there's actually like those batteries that you put into it. Those are just like the regular batteries it uses, but there's a backup battery too, so that's why it lasts so long and like kind of gives you a warning. So maybe your regular battery in the inside went out. So anyway, there's a way to find these coefficients. Like if I wanted to find the 13th row, I can find that 13th row without writing the first 12 rows to find it. Okay. So Pascal's triangle, you know, goes 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So on my probability finalist probability, which we use these all the time in probability, I had to draw like a 10 row Pascal's triangle, and I'm sure my professor was like, what an idiot. Like, why did she do this? Why didn't she just use her calculator? But I did okay, so I don't know if I'd ever told him that I needed to do that. So anyway. So let's say I have something like this. I have the first 6 rows. If I want to find, let's say, this term right here, that is in the 5th row. And I call this the 0 item. So this one would be the first item. What item is it? So 0, 1, 2, 3, 4. It's the 5th row, 4th item. Don't you hate that with having the 0? You're like, oh, why is it the 4th item? It should be the 5th. Okay, 5th row, 4th item. If I want to find that on my calculator, I can do something that's called NCR. It's called a combination, NCR. Okay, so I can find it by doing 5, right, for the row it's in. And then I hit math, so go ahead and do this along with me. So I hit 5, and then I hit math, and I arrow over along the top when I hit math to PRB, because like I said, we use this a lot in probability, PRB. And then I choose NCR. So NCR, and then I put in 4. Do you see how it gives me the number 5? That was the item that I had circled, the number 5. Okay, so if I want, like I said, the 13th row and maybe the 2nd item, I would do 13 NCR 2. We call that choosing. 13 choose 2 is how I'll often read that. Okay, so as we do these problems, we're going to use that. So it says in chapter 12, we're going to learn a lot more about combinations. In the meantime, we're going to use our calculator to compute C and R. Now, I often will notate this as N over R in parentheses, no fraction. It's not a fraction. N over R. Okay, so we read that N choose R. Okay, so maybe I'll let you guys go on your break first, and then, is it at 20 when you guys get your break? And then we'll do this one? Okay. So go on your break, and then we'll talk about this. Okay, so it says in chapter 12, we're going to learn about combinations. So we just talked about this. So we have this NCR. Shh, guys, NCR. So back when I taught at IU, we would always have these questions on the test. It would be like the one that was on the backboard. It's crazy, crazy long. All right, so it'd say find the coefficient on the x to the fourth, y to the ninth term of the expansion. And I would have students that would do what Allison Klein did on that backboard, and they would write it all out, and then they would find that middle term, right, the x to the fourth, y to the ninth term. You do not have to multiply that all out. You don't have to figure out the whole expansion. I'm just asking you for that particular term, okay? Does this make sense, Kyle? You with me? Okay, so let's kind of think about the pattern with the expansion, and then we're going to shortcut it even more. Okay, so here's what it looks like. So if I have a combination, I told you I typically write it with parentheses, and I do n choose r, like n on top, r on the bottom. You guys are making me nervous back there. All right, so for this, I would do 13, choose 0 for the very first one. I would have the x raised to the 13, and then I would have negative 2y no times, right, 0 times. So I'm going to write it for this first part. Then the next term would be whatever 13 choose 1 is, meaning whatever in Pascal's triangle is in the 13th row and the first item, meaning the 0 item, then first item, right? And then I would have the x raised to the 13, and then I have negative 2y to the 1. All right, and then the next one continues. You have 13 choose 2, you have x raised to the 12, and then negative 2y raised to the, oh, did I mess something up? I did 13 again, didn't I? Is that why I saw someone with a crinkled nose? Like, why do we have that? All right, 12. They need to add to be 13. All right, so like I'm saying, the next one would be 13 choose 2. You'd have x to the 11, and you'd have negative 2y to the 2. And this pattern would continue until you get something with x to the 0, negative 2y to the 13. Do you understand what I'm saying? So if I want something to have an x to the 4 and a y to the 9 in it, what thing needs to be raised to the 4? What thing needs to be raised to the 9? The x part needs to be raised to the 4, and the negative 2y part needs to be raised to the 9. What combination, what number is going to be in the front? Like 13 choose what? What's the pattern? 13 choose, look at it, 13 choose 0, x to 13, it's 13 choose 9, right? Does that make sense? It's the second number. So here and here. So what I've written up here is totally useless. I was just kind of showing you the pattern. That's okay. I'm showing you the pattern. All you need to do is identify what term you need and write the correct power among those. So let's find these. So let's do 13 choose 9. So right before break, I showed you how to do this. So we're going to hit 13. We're going to find NCR. So along the left-hand side, we're going to hit math. We're going to go over to PRB, option 3. So 13 NCR 9. So it's going to be 715. Did you guys get 715? Did you do NPR or NCR?
Wait, what are you supposed to do again?
13 NCR 9.
Oh,
715. All right, then I have my x to the 4th, and then I have my negative 2y raised to the 9. So if I have negative 2 and I raise that to the 9, I'm going to have negative 512. So when I multiply this out, so I have negative 512y to the 9th, I guess I should say. So I get negative 366,080 x to the 4th, y to the 9th. That is my answer. So when it asks for the coefficient on the x to the 4th, y to the 9th term, it's this right here. That's my coefficient, the number out front. So let's do the same thing on the next one. So see how the next one starts out? I have 2x plus 3 raised to the 10. That means everything's going to have to do with 10. Okay, so I could do the whole expansion, and it could take forever. And like I said, my IU students would always take forever. They would write this whole thing out. And like, you just wasted 10 minutes of the exam by doing this. You only need that one thing. You need the x to the 8th term. Yeah, so if I need the x to the 8th term, that means this part right here, the 2x that needs to be the part that's raised to the 8th. That's the only way I'm going to get x to the 8th. If I raise it to the 7th, I would have something with x to the 7th. All right, and then the other part, the 3 needs to be raised to the what? Not 10. 2, they need to add to be 10. Those powers add to be 10. So I'm trying to write in there very tiny, add to 10. All right, and then out front, what do I have? So I have 10, choose what? Choose 2, the last number. It actually works out. If you did 10, choose 8, I heard a couple of you guys say that. 10, choose 8 is the same as 10, choose 2. Think about Pascal's triangle. It's very symmetric. Why would that work? So combinations, I would say, are like committees. We're going to talk about this a lot more in chapter 12. But if I say Mr. Morrison has 10 people, Jason, if Mr. Morrison has 10 people interested in a volunteer opportunity, but he can only take 4 with him in his car, how many ways can he select the 4 people to go in his car? Right? It's 10 people. I'm choosing a group of 4 people. Okay, that's a committee thing. Think about what we're doing. We're saying 10 people. I'm choosing 4. Guys, you're driving me crazy. I'm picking 4 people to go with him. How many people am I choosing to not go with them? 6. So it's the same thing. Do you see? Choosing the 4 is the same as choosing the 6 to not go. That's why those numbers are always the same. Okay, so anyway, so let's do 10, choose 2. So 10, math, NCR, 2. So we get 45. And then I have my 2x to the 8th. So if I do 2 to the 8th, I get 256 x to the 8th. And then if I do the 3 squared is 9. So I have 45 times 256 times 9. So my answer is 103,680 x to the 8th. So my coefficient, 103,680. That's your answer. Does that make sense? Can you imagine how long this would take to do every single term? It would take forever. Don't do that. It's lazy. All right, do you guys feel good about those? Do you need one more? Yeah.
Why are you able to do like 45 times 250x to the 8? Why are you able to multiply those numbers?
It's not like you're adding where you have to like terms, like multiplication you can multiply. Like 2 times 3x is 6x, right?
Oh,
That makes sense. You're thinking of like terms. Okay.